What's going on, gamers? We'll get started in a couple minutes here. Oh, man. Yeah, let's pause that and pause that. There we go. What's up, Matthias? How you doing? Hi from Chile. Yo, welcome, welcome. What's up, NMBB? You get the first person here in either chats award. Look at that. Oh man. Yo, look at this. Look at this gnarly pimple up here. Ugh, God. I'm a grown man. You think I would have outgrown pimples, but here we are. Oh, you can't even hear that. What's up, Deagle? How you doing? Just like a teenager. Exactly. God. That was a long time ago. I thought I could leave those days behind me. Are you playing piano with your keyboard? Yeah. That's exactly what I'm doing. Here, I'll show you. No, I have a musical keyboard right in front of me. A lot of people don't realize that. So yes, I am using a keyboard, but not the one you think. Any tips to improve in piano? Started a couple of months ago in classical piano lessons. You know, ooh, okay. Oh man, if you're just getting started, my only tip is practice. Like literally, like my only tip is like practice. Like, it sounds stupid, but if you're just learning, like your fingers need to learn how to move, your hands need to learn how to move. So you're only going to get there by doing the most boring scales. Like literally, like. You get the nice contrasting motion. Or was the opposite of contrasting? Because contrasting is what, like this? That's easy. Because you're using the same fingers on each hand, they're just mirrored. The hard one is when they go together. And you'll just learn these basic like techniques. This is the most important thing I would say while learning. Don't rush it. Play with a metronome. Focus on accuracy over anything else. It will make such a difference. I promise you. That's why my fingers I just look at some keys and my fingers will find a way to get there. Usually in a good way. Sometimes in a bad way, and you have to teach them the right way. 7-hour piano tutorial. Worked for Bash or worked for piano. Yeah, my whole channel is just 7-hour tutorial videos, nothing else. Alright, what time is it? Let's see. This is an awkward camera angle. There you go. Look at my beautiful face. Alright. I also got food on the way, so I will be taking a little break to... Well, not a little break. I just have to go get the door. I got some Pizza Hut delivery coming here. So excited for it. To make up for like a couple nights ago when I said I was going to order pizza and I just didn't. How did you do that camera angle switch so fast? Is that some hardware that moved the camera? Yes, I use an Instalink 360. It's like a webcam or whatever, but it has this software where I can actually just like move it around. So I have this like piece of software over here. You can't see it, it's just off screen, where I can just like do this. Wait, is it doing anything? Hold on. There you go. But then I can have it snap to a couple views. So I have two really quick views I can snap between. But it actually physically moves the thing. Like the thing's on a gimbal, a really small gimbal, and it just moves it. So yeah, I'm a big fan of this webcam. It's like good quality, you know? Hello, Dave. I just had lunch. Huge bone in oven for 30 minutes. Under it, throw on last 15 minutes. Turkish type bread. Yo, that's awesome. Welcome. I have food being delivered here right now. I'm getting a cheese pizza from Pizza Hut. Of course, it is, 10:30 at night where I am, but, hey, whatever. We don't judge here. I don't judge here. All right, so let's go ahead and let me check out the leaderboards. Okay, so as you can see, we have a new leaderboard. So if you're watching in Twitch, Bad Cop set this up for me. This is a nice little leaderboard of who gets to the channel first. So I think if you get to my channel on Twitch, you can redeem a thing. I don't know how it works. You can redeem a first or second thing. I honestly have no idea how it works. I'm not the most, like, Twitch-enabled person. I'm going to be real with y'all. It's never too late for pizza. Dude, I agree. I agree wholeheartedly with that. Nice plane, by the way. Thank you. That's so nice. Oh, look at that. Jeff, nice job pulling ahead. Yeah, Jeff, I don't know if I pull in the viewership that Bad Cop does, to be honest. Like, Bad Cop crushes it on Twitch. Her numbers on Twitch are amazing. Like, don't get me wrong, I'm thrilled to have 800 followers on Twitch, and I love that the chat gets going, but I do not have the viewership that she does over on Twitch. She crushes me there. I'm not really a streamer. I would consider myself more of like a long-form content creator. I like streaming, don't get me wrong, I do it for fun, but like, I think people watch, okay, let me take this back. I don't think people watch my long-form YouTube videos more. I know that they do. I have the analytics. I know that that's my bread and butter. Bad Cop is the GOAT, dude. That's so true. All right, what do we got going on here? Ooh, pizza's on its way. Let's go. Oh, man. All right. 10, 15 minutes. Not bad. Bread, dude. So true. I had a follower goal on Twitch? Heck yeah. 810 followers now. Look at that. So I have 810 followers on Twitch, which is very similar to the 70,000 subscribers I have on YouTube, where I'm dual streaming too. That's really funny. Oh my god, it's so windy out. What was I gonna say? Actually, I don't even know what my YouTube subscriber count is. Let me go pull it up. I can pull up the live one, which is pretty cool. There's like a way to view it, like in a really cool live way that you can like share publicly. Oh yeah, look at this. Okay, check this out. I pulled this up. This is my YouTube channel, You Suck at Programming, and it has a live subscriber count, and it is just, it's crazy. Like, you can see the growth just like taking off here. Like, do you know what happened here? That's when I released the bash course. Like, that was the bash course right there. So, yeah. I appreciate everyone who's hit that subscribe button on YouTube. It's super cool to see that number go up. Like, I know I constantly say it. Like, I don't know how you guys feel about it. A lot of people on YouTube, like, you know, they have brand deals. They have sponsorships, or they sell you their course, or they sell you different things. They're selling you something. I'm not doing that, but hold on. This isn't, oh, look how high and mighty I am. Look how much better. That's not what I'm doing here. I'm just saying I'm not doing that. But I like to like joke around that I am. So when you're watching one of my videos, I'm like, by the way, I do have a 7-hour bash course available. And then my pinned comment will talk about it. But like the funny part is when you click it, there's no sign up. Like it's actually free. I don't know. I get annoyed. People will be like, we have a free thing here. And you go there and you have to put your credit card information. It's a free trial for like 2 days. And if you don't hit cancel, then they charge you like $8,000. It's like, dude, come on. That's not cool, man. So I don't know. I guess what I'm saying is I hope you guys do appreciate that when I say, hey, I got this free thing for sale. Like, it's actually free. Also, in the future with YouTube videos, I may start taking brand deals or sponsorships. Let me rephrase. I'm open to brand deals and sponsorships, but so far I don't know. I haven't found any companies I really want to work with. I'd probably have to go out of my way to find them. The companies that email me are like these fake AI scam products. And I'm like, dude, I have no interest in that. So I might start doing that in the future because it's a good way to like, you know, bring in some income. But like the nice thing is right now where I am, it's not important. I have a full-time job. I don't rely on this. So this is just like a fun hobby I have. And I don't know. I kind of like it that way. I think it's fun. Hi, good morning. Hello. What's up, Harsh? How you doing? What's up, Fallen Learns? How you doing? We do appreciate that. Thank you, NMBB from YouTube. I love how you're just like in different chats. You should make a video about RAM prices. Speaking of long form content, that would be kind of fun. I don't know how much insight I have to give there because that's like more news and less like, I don't know how much of a technical breakdown I could give there. I guess I could talk about like, you know, the wafers versus the actual storage space, like why buying like a 64 gig stick of RAM would be different than buying a 128 gig stick of RAM, but it's not really that much different. Like even though it's double the storage, like the wafer, like there's things I could talk about, but I don't know how much insight I could really give that would be useful there. I think it's better to stream than getting paid to some office, have to drive there, pay tolls, massive driving costs. Oh, dude, I mean, if I could make streaming my full-time job, yeah, absolutely. I don't get paid nearly enough. Like, I couldn't live off of what I'm making on YouTube. It's just, like, hobby side money right now, which is super cool. I'm appreciative of it. It's appreciated. Yo, thank you, thank you. Hey, what's up? How you doing, Sashi? Welcome. I switched to Twitch for that Basha thing that you were showing us. Honestly, I have no idea what's going on there. Yeah, apparently, like, I have channel points and you can redeem them for, like, some things maybe that are called first, second, or third. I don't quite know. I don't fully understand. But then it gets you onto the leaderboard here. So if you have channel points, I think, like, in the bottom left of the chat, there should be something and you can click there and there'll be different redeems. And there should be one, like, there should be one that costs 1 point, and it will be first, second, or third. I think that's how it works. But, you know, you got to double check that. Look at that. There we go. NMDB from YouTube, redeemed second. So if I refresh this, look at that. Okay, so you must get 3 points for second and 5 points for first. That's pretty cool. So it's a cool way to see who's coming to the stream. Obviously, you know a lot about Linux. Have you thought about doing a course or video on cybersecurity? For example, privilege escalation with SUID, the kind of thing, or something Linux hardening? I haven't thought about that because I'm just not interested in security that much. It's just not something that interests me so much. There's definitely viewership in it. People love security videos. People love hacking videos. Oh my God. I just worry about the audience that it would cultivate. Like, I see a lot of the people that comment on hacking videos, and a lot of them just seem like kids. I'm not hating, but like a lot of the comments on videos, like, here's how to hack this, and it's like 12-year-olds being like, you know, my uncle hacked this, and I work at this, you know, he works at this company. I'm like, dude, I don't know, it doesn't interest me. The security and hardening stuff could definitely be cool. Maybe I'll do something like that in the future. But yeah, like I said, it's like I'm more interested in sysadmin and writing code. So like the security stuff, I don't know it as well, and I don't personally have as much of an interest in it. So definitely something I could talk about, but if I'm talking about something I'm not 100% interested in, it might come across as like boring or something. Like I think people like some of the videos because like they're like, Dave, you're so passionate about this. It's like, dude, I like this stuff. Yeah, of course I'm passionate. Look at that. Oh, another subscriber. Thank you everyone for hitting that subscribe button on YouTube. That is super cool. I recorded the Bash course almost a month ago. I think a little bit less than a month ago. And at the time of recording, I had about 62,000 subs. So we've gained about 9,000 subscribers in a month. That's unreal. That's unreal. I can't keep that pace up. But like that 100,000 subscriber play button on YouTube, it's coming. It's coming, and I'm going to have a silver play button from YouTube. That is crazy to think. That's crazy to say out loud. That is a wild thing that I can't really wrap my head around. So that'll be a ton of fun when that actually hits. Oh man. Oh, you know what I could do actually while we're just sitting here waiting, because my pizza's gonna get here in 5 minutes. I'll eat that and then we'll get started writing some actual code, and I can talk about what we're gonna write. We have xmas.ysap.sh, which we worked on a couple nights ago on stream, so I can just have this little animation coming. And then one of the users, Kaner, I don't know actually pronounce their name, Kaner, I don't know. One person actually made a pull request and fixed one of the issues that they were running into where it wasn't cleaning up the terminal on exit, which was a really interesting bug that had to do with different languages and how a lowercase I was being processed. So super fun. I would say go to the repo and check out the pull request if you're interested in that kind of like stuff. Otherwise, this is beautiful. Look at this. Oh, do we need some music to go with it? I could, the Turkish eye. Yes, that's exactly what it was. It was because the lowercase exit. Actually, here, I'll show you. xmas.ysap. Let's pull the latest thing. Do a nice little git log. Here we go. Capitalize exit for laying equals trtr utf8. So yeah, go to the pull request if you want to see it. But the change for that was just to change the lowercase exit to all caps exit. So this is definitely something I'll be keeping in mind. I could have set like LC all or something to C or UTF-8 or ENUS or something, but this seemed to fix it. So very, very interesting. Just kind of cool to see. But now we have this little beautiful animation. I just moved to Twitch for the leaderboard. Dude, okay. Oh man. That's so funny. I'm glad that people are motivated by the leaderboard. Like I think that's super cool. I need to get better at that. I need to get better at like offering people incentives to do things. Not like weirdly manipulative or anything, but just like here's an incentive to like go to the stream. I want to give people incentives to like comment on videos. You know, people do like giveaways and stuff, but a lot of that stuff just feels cheap to me. I want it to feel fun and not like trying to extract something out of people. So like a leaderboard's a fun thing. It's like so low stakes, you know what I mean? So I like that. Let's go back here. I like this little animation going. That Christmas animation is really nice. I love it. I think it's great. Were you here on stream a couple nights ago when we wrote it? Because, you know, this is all bash code. And we wrote it on stream. So that is pretty cool. Okay, is it Matthias? Am I saying that right? From YouTube? Nice. Linux has a special framework that, besides generically provided, allows to control execution under what conditions it's chroot related. Linux has a lot of stuff, I can say that much. Yeah, I love this. I love this whole Christmas thing. It is so nice. Oh man, I should. Okay, hear me out. I'm not going to add features to it. Because we spent a long time adding features. Yeah, Ogre. If you want to go check out the VOD, you can. It's a long time. I'm currently cutting up the VOD to become a YouTube video that I'll release on Christmas Day. And I'm thinking about turning that into a tradition where I'll live stream in December. We'll make a new version of this, and then I'll release the video on Christmas Day. So if you want to wait for the edited VOD, you can. I'll cut out a lot of the downtime. But if you just want like the whole live stream experience, yeah, I'd say go check it out. Because we run into some fun bugs and all sorts of stuff. I would like this area right here to have a custom message. Like I would love to be able to give a custom message maybe over standard input or something. That could be kind of cool. I don't know. I don't want to add features to it, but you know, add too many features to it, but that might be a cool thing. It would be cool if it also played the Christmas 8-bit song. Yeah, you know what? I was even thinking about that because like I could open up another thing here. The screen is too small to do this. How many columns do I have? 148. Is it the lines that is yelling about? 44. It is yelling about the lines. Oh, and that broke that. That's nice. Here's what we'll do. We'll get that going. We'll open up another one of these. We'll shrink it down really low. And I'll put it in the background so you guys don't have to see the terminal. Curl nightfall.ysap.sh pipe to bash. There we go. So what you can't see is I have another terminal going over here, which has my album on it. and I'll just play some music off of it for us, like very piano-y. We'll do Echoes of Solace. How's the music? Is it too loud? Is it good? You guys gotta let me know how it is. Is it annoying when I play piano on top of it? I'll probably disconnect soon. It's getting late here, so I just want to say thank you. I usually program only in Python, but with your videos now and streams, I've been learning a lot about Bash, dude. That's awesome. Thank you for jumping in. I appreciate it. You ready? Oh, it's the best part. I might be deaf, but I don't hear your piano. Oh, okay. It might be too quiet. Find your channel recently set some suggested videos. Good sharing setup for this sort of content. Yo, appreciate it. I'm glad you're here. That's awesome. Oh, it's the best part of the song. I'm gonna say it like 10 different times. So yeah, if anyone's just joining, this is an animation that we wrote on stream, and you can run it in your own terminal. I'll show you the command for that in a second. And also, this song that you're hearing is a song that I wrote off my album called Nightfall, and the song is called Echoes of Solace. And if you want to listen to this, you can also listen to it in your terminal, because we're insane and we write fun things here. Alright, I'm gonna be right back. My food's here. Yo, I'm back. Is it pizza? What a crazy question. Absolutely it is. And I won't eat it on stream and make you guys suffer through having to listen to that. So I'll mute while I eat it. What's up, Wishmaster? How you doing? Beautiful Bash holiday scenery. Yeah, I know. I love it. We got the music going too. These are original pieces by me, so we don't have to worry about copyright strikes. So yeah, we're listening to music that I wrote with a little animation that we made. So ton of fun. Let me get that cursor out of there. I've been doing the Synacor challenge over the past couple of days. It's absolutely insane. I love it. Dude, I'm excited. I'm afraid to see like what's involved with it, but I'm very excited. Is the sauce any good? The sauce is wonderful. It's a Pizza Hut. I got a Pizza Hut medium cheese pan pizza. I think I'll eat 3 slices of my 3rd slice here. Dude, leftover pizza is still so good. Only for like a day. After that, it kind of starts tasting like cardboard. Papa John's after like 12 hours starts tasting like cardboard. Domino's after 5 minutes starts tasting like cardboard. I still love it, but you know. NMBB, are you thinking it might be Carol the Bells? The da na 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 na. I play that song a lot, so you might be thinking of Carol of the Bells. Yeah, I wouldn't recommend more than a day for that pizza. Have you tried Zig before? If yes, what do you think about it? I have not tried it, so I couldn't tell you. NMBP, that's really funny. It's a Ukrainian song, you're like, yeah, I never heard of it. Also, guys, gotta let me know what you think about this song, okay? This song's called The Final Storm. It's the end of the album. It is the... Oh... I think it's one of the best pieces I've ever written. I finished it up around the end of 2023. It wouldn't get released till later, but like this was one of the last songs I finished on the album. Synacor website isn't loading. Yeah, I don't know exactly how to get information about this challenge. I just know it's hosted on a GitHub that Aneurysm has, who's one of the community members for Advent Opcode, so we'll be using that. We'll be pulling it down from that. I'll show that in a second when I pull back up the browser. Switch up. Back to normal. Now, what am I doing? There we go. This is nicer to look at. All right. I'm going to unceremoniously stop this music. There we go. Okay, now we can focus again. And it's time to lock in, so... How's the volume sound there? Does it sound good? Like, can I talk over it? Does it sound fine? You can read some info off the Internet Archive, but it's down. Have to get it from people's repos. Yeah, I'm hoping that what Aneurysm has is well, I'll pull it up on GitHub. I hope that's going to be enough for this challenge. I think it will be, but we'll pull it up and we'll see. Yeah, Synacor's a real company. I guess Eric used to work there, but that was a long time ago, so the official challenge is not there, so we just have to get it through, like, some historical stuff here. Which is a shame, but, like, at least it's still preserved. At least I can go through it now. This is really nice. Was really nice. Thank you, I appreciate that. What music player do you use? For that thing, or just in general? Because, like, for that thing, I was using FF Play, which is part of FFmpeg. So FFmpeg will ship with an FF Play binary sometimes, and you can use it to play music. Do you have sheets for your songs? No, I do not. I just recorded all MIDI input and then go there. So, all right. Let's lock in. Let's jump in. Let's start seeing what we got going on here. So, oh, excuse me. Oof, wow, that was a lot of food. That was a little bit too much food too quickly. Oh, that was delicious. Oh my God, Pizza Hut's so good. All right. So we have the leaderboard here. We have the channel analytics here. Oh my God, I've gained 10 subscribers in the last, what, like 5 minutes, 10 minutes? Am I getting a subscriber a minute? Oh, that's pretty awesome. So yeah, if you're watching on YouTube, you know, just go ahead and hit the subscribe button. But I assume if you're watching me, you're probably already subscribed. So let's just jump in. Let me stop messing around here and let's go on over here. The leaderboard is a Twitch specific thing. Bad Cop set it up for me, and I guess like a bunch of other people are on it as well. So yeah, it's called first.bashstack, and a bunch of different streamers are using it. So I got mine on here, and you can see, so when I go live on Twitch, if you're in my Twitch chat, you can redeem a first, second, or third redeemable thing, and then you get points based on it. So Jeff was first today, Bad Cop was first yesterday, and everyone else here was second either or yesterday, 2 days ago. I don't know. So something like that. I don't know exactly how it works. I'm gonna be totally honest. So, all right, what we have here is the Synacor challenge. And so Eric from Advent of Code, who's been making Advent of Code since 2015, before that in 2012, there was a challenge for a company he worked for at the time, Synacor, and this was presented at OSCON in 2012. So I don't know much about this. I know that there are some MD5 hashes of the 8 codes produced by this instance of the challenge for use in testing implementation of the architecture. These codes can be verified as followed, and there are some MD5 hashes. I don't even know what these are. I don't know what we're going to use here. So we're kind of going in here blind. Hey, YSAP. Yo, what up? What up, Bat Kitty? How you doing? So we're going to clone this because I looked through it just a little bit, and I have a rough idea of what it is. Let me fire it over here on the terminal. There we go. All I've done is clone that repo. So we're going to go to VM challenge. So if you guys want to clone it and follow along at home, you can. I should probably make my own repo for this. We'll do that. We'll do that. But let's take a look at what we have here. So we have the archspec and challenge.bin. Archspec is executable. It's interesting. What is in it? It's a text file. Probably shouldn't be executable, but, you know, hey, here we are. So the Synacor OSCON 2012 challenge. In this challenge, your job is to use this architecture spec, so this file, to create a virtual machine capable of running the included binary. Along the way, you will find codes. Submit these to the challenge website to track your progress. Good luck. So we're not going to have the challenge website, so I think we're just going to have the MD5s to verify that we were able to extract the codes. So I think we're going to have to do some self-verification. We have a challenge.bin file, which looks like it's just data, and it is 59 kilobits. So 59 kilobytes, not kilobits. So 59,914 bytes of data in this random challenge.bin file. So let's fire back open that arch spec. Okay, the architecture. There are 3 storage regions. Cool. Memory with 15-bit address space storing 16-bit values. So the address space is 15-bit, and when you go to that address, you will get a 16-bit value. Okay, so 2 bytes. There are 8 registers, and there's an unbound stack which holds individual 16-bit values. Okay, so we're making a computer here. All numbers are unsigned integers, so 0 to 32,767, 15-bit. Okay. Yeah, that makes sense. Okay, so just 15-bit numbers. All math is module 32,768. Okay, so you just, if you overflow, you just get like modularly divided. You just lose that bit. It just gets truncated. Okay, I mean this is simple. That's like all computers. I'm gonna turn my phone off. I'm getting blasted with notifications. So, okay. We have a binary format here. Each number is stored as a 16-bit little endian pair, low byte and high byte. Okay, so we're storing it in little endian. Interesting. Numbers 0 through 32,767 mean a literal value. 32,768 to 32,775. So that is... Wait, hold on. Am I reading this wrong? Numbers are 32,767. That's 15-bit. And then if the number is above that, it means referencing a register, or these are invalid. Oh, because they hold 16-bit values. Okay. So if it's this much above 16 bits, if the 16th bit is turned on, and then what's valid is 0 through 7, that means it's a register. Anything above that is just going to be invalid. Okay. Okay. Interesting. Okay. I don't understand. Are we going to write a VM? I think that's exactly what we're doing. I think that's exactly what this challenge is. Arrow port 2, what's up? What is this? It's a challenge where we are given a binary file and we don't know much about it. It's literally just binary data in this file. That's 59 kilobytes of data. And we have to figure out how to extract data out of it. We're going to have to reverse engineer it and make a computer that can basically like execute this binary, I think. I'll show you the document here because it's not that big of a document. Execution. No, sorry. Binary format. Programs are loaded into memory starting at address 0. Okay, so we always start at the beginning. Address 0 is the first 16-bit value. Address 1 is the second 16-bit value. Okay, so adder 0 is at byte 0. Adder 1 is at byte 2. Adder 2 is at byte 4. Okay, I'm following this. After an operation is executed, the next instruction to read is immediately after the last argument of the current operation. If a jump was performed, the next operation is instead the exact destination of the jump. Encountering a register as an operation argument should be taken as reading from the register or setting into the register as appropriate. Okay. Hints. Start with operations 0, 19, and 21. So I think these are the operations down here. Oh boy, okay. Okay, there's only 21 instructions, 21 operations or instructions. I think that they're using them interchangeably here. So start with operations 0, 19, and 21. 0 is halt, which just means to stop. 19 is write the character represented by ASCII code to the terminal. Okay. And 21 is a no-op. Okay, I mean, yeah, that's simple. Let's see. Here's a code for the challenge website. I do not know what this means. Like, I don't think the challenge website is up anymore. I actually don't know what that means. So, I mean, yeah, Bob Null, if you're the only person who would know what this is, maybe we just ignore it. Maybe it comes in handy. I don't know. Maybe they'll ask us. Maybe as I get going, things will be revealed to me. The program 9, this, that occupies 6 memory addresses. 1, 2, 3, 4, 5, 6. That makes sense. And it should store into register 0 the sum of 4 and the value contained in register 1. Okay. So this program, which starts at 9. Let's go down here. Let's find 9. 9 is to add A, B, and C together. Oh my god. Okay. Okay. 9 A, B, C. Assign into A. So A is probably going to be a register. The sum of B and C. Okay. So if we have 9 here, we assign into A, which is 32,768, which is register 0, this number, and 4. So this should be the sum of 4 and the value contained in register 1. So this is register 1. Okay. Output to the terminal, the character with the ASCII code contained at register 0. So output to the terminal is 19. And then 32768 is the code for register 0. Okay, that makes sense. What are the registers initialized at? 0? That will tell you if things are functioning correctly and if you're on track. Okay, cool. Thank you. Does it say what the register's default value is? I'm assuming it's 0, but have I not read that? I don't know if I've read that, but maybe that's a safe assumption, or maybe not. I mean, I'm trying to think of computers I've dealt with in the past. The registers are undefined until you set them on a lot of machines. So, yeah, operation is a complete instruction. For example, push to A. Oh, okay, instruction would be push, and the operation would be all that together. So the instruction and the operands together, the arguments or whatever you want to say. Okay, that makes sense. Yo, Stu Square, what's up? Hell yeah, dude. Yeah, dude, we're doing it. We're jumping in. We're trying to see what the Synacor challenge is all about. I'm excited. I try not to spoil like any of it. Besides knowing I'm making a VM, that's it. So, oh man. Let's see. As I suck at programming, my first instinct is to copy and paste this into ChatGPT. Yeah, don't do that. You will just be doing yourself a disservice by doing that. Absolutely don't do that. That's insulting to your own brain to do that. Sit there, try and understand it, try your best to understand it. I don't know. Like, I could learn to solve a Rubik's Cube, or I could upload a picture to a website to have it solve it for me. One of them is way more satisfying than the other. Let's see. YouTube ate my last message. MD5 the codes and check against the list in the repo. Oh, okay. I see. So that's how you verify the program you got. Gotcha. Sup, Dave? Congrats on the Bash course. It's awesome. Rapid. Thank you so much. I appreciate that. By the way, if you're just joining in, you want to learn how to write Bash, I have a Bash course. It's free. It's free. Not some lame, like, oh, there's a free trial, and then I secretly charge you, or, oh, I need your credit card information, or I need your email. No, I don't need any of that. It's completely free. Go check it out on my YouTube. It's literally a 7-hour video. That's it. That's all I got there. This is an LLM free zone. Absolutely it is. Yeah. We are an LLM free channel over here. Let's see. Registers can have anything in them, no default 0. Yeah, see, I haven't read anything about a default. I don't think I've skipped it. I think we should just make the assumptions that the registers initialize with 0. Because like here we go. Like, I'm looking at this program here, right? And the first thing it does is 9, which is add, and we add A, B, and C. So the first thing it adds is 32768 and 32769. It stores it in 32768 and it adds these two numbers together. So store into register 0, the sum of 4 and the value contained in register 1. I get that makes sense, but like as a starting program, would we just assume that's 0 at first? So yeah. The Bash course is high quality. Yeah, appreciate that. Thank you. So I'm just going to assume it all starts at 0. I think that might be our safest assumption. I guess all we need to do is start just implementing this. I guess I'm curious. Because if I just implement this whole VM, and I run the binary through the VM, does the... Oh God, is it gonna... Oh, okay, hold on. I'm cooking now. If I successfully run it through the... I'm willing to guess that it prints out more text for me. And it's going to... Like, I'm going to jump through a series of channels. That's my guess. We're going to see if it actually works that way. Because I'm just like... I'm looking at this, I'm like, okay, so I just implement a VM. Like, yeah, it'll be a little bit tedious, and we got to test it and stuff. But like, you know, I don't know. All right, let's get started here. Let's make our own repo. What should we call it? Synacor challenge. There we go. Get it dot. There we go. And we will cargo new dot. No, wait, doesn't that work? Oh, not cargo new, cargo net. There we go. So I think that's all we need, right? To just make a new Rust project, Synacor challenge. Yeah. Initial commit. There we go. So now in here we can CP the, well, I guess we'll bring both over, the arch spec and the challenge .bin here, and we'll put that in the git ignore. So the arch spec and the challenge .bin file. So we won't have them. Cargo B. I was waiting for the bash virtual machine. Nah, dude, check the title. We're doing it in Rust. I don't even want to attempt this in bash. I'd be so afraid. I think this is going to be a tough challenge, so I'm ready to just do this in a language that can handle binary data more easily than bash can. So let's think about what we want to do here. Let's get the arguments. Do you get the first argument or not in Rust? I don't remember. Okay, so we do get the first one, so we just gotta chop that one off. Can you just skip one, I think? There we go. Okay, so we'll say let bin file equal args 0. So now we have the binary file. I think because the binary file is only, what is it? It's not that big. 59K. We're just going to read it into memory. I think we're going to read the whole thing into memory, and we're going to read it as a vec of bytes. So we can do that with, I have to remember this off the top of my head. Well, I don't have to. I can look it up. Is it just fs read? Do you just give it the bin file? Cargo run dash q the challenge.bin. There we go. So there's the entire file as a vec of bytes. So, hey, not too bad. So what do we do with this information now? We need to start implementing the virtual machine. So what's our arch spec look like? Vim arch spec source main. Let's go ahead and grab all this, go into our source code, and let's put it down here. So let's start thinking about how we want to implement this, because I'm thinking we're going to want to make some sort of like machine struct that we can load with a ROM file. So let's start imagining what that would look like. So we'd have a struct like VM, virtual machine, and that will have a ROM file, which is a vec of bytes, and we'll probably have a function to step through it. It'll have registers. I think there's 8 registers. I wonder, trying to think what we want to store in the actual register file, because we could just do like, we could do like register 0, register, like we could just do all of them like this, or we could just say register is a, oh, can you do this? Can I say it's a this of U16 with a length of 8? Is that valid Rust syntax? I mean, the rest of it isn't. Okay, so that's valid. Nice. Cool, perfect. Okay, so we have the ROM file, we have the register. Do we, does it make sense to put the S here? Like registers, then we give it spot 0, spot 1, spot 2. I'm gonna leave it as registers. I think that makes sense. We have the ROM files, we have the registers. Now we're gonna need some functions on it. So impl VM, probably a, we don't need, I'm not gonna do like a load ROM file or modify register. We'll worry about that later. Probably debug printing it would be useful. I guess we just need a that wind is crazy. An instruction pointer, right? And the pointer is, they are 16-bit addresses. Okay. So we have the ROM file, the registers, and the pointer. I think we need functions like step, which will take, it has to be able to modify itself. So it'll take a mutable reference to self. And I don't think it needs to return anything yet. We'll figure that out. And this will step through a single instruction. Okay. So grab the instruction to process. So the instruction that we want to process is the ROM file at self.pointer. Okay. Also, we should probably let's do this. We should probably make like a an initialization thing. Can you share the GitHub link for the challenge, please? Yeah, definitely. It's right here. I guess let me grab this. I can put it in the chat. I'll pin it in both chats. There we go. So it should be pinned in both chats now. So now we just need like an initialize thing, like a new function, which will take the ROM file. Should it be called the ROM file? It should probably just be called ROM. It's not the ROM file. We don't actually care it's a file. It's just the ROM. It's the read-only memory. So we'll take the ROM, which will be a vec of bytes. And we will take the nothing else. And that will return a self. And this will return self, where the ROM is that. The registers are... Oh man, is there like a rusty way of saying just initialize all this stuff to 0? Can I just do this? Is that valid? We're going to find out. I'm just making up syntax here. Yeah, no problem, Jonas. Slice indicators are type usize or ranges of usize. Oh, because we're trying to slice into it. That's crazy that it can't be indexed by that. Like, that seems crazy, right? Oh, U of 16. But yeah, wouldn't this still work, though? Like if I just put O here without the type, because it knows that I'm trying to put it into the U16 up here. So when the compiler just know the right type for this. I mean, it's yelling at this type. So we can just do a little whoopsies. Okay, that's good to know. But yeah, Bob, like if I wanted the actual like very specific thing, that's good to remember because I oftentimes forget that I can just do like that. So that is really good. Registers are auto to 0. That's how I'm treating them. My understanding of it, I'm just going to treat that as that. That might change in the future. I haven't seen anything there, but yeah. All right. I feel like step should return something because the process can halt. So let me think. Default all the things. Oh, you're totally right. I could totally just do that. I'm going to leave it like this for now, but yeah, I totally could have just done like the default. What do they call it? The splat operator, I think is what it's called. So yeah, I'm going to leave it like this in case we have to change it in the future, but should be good. So let's do this. Let VM equals VM new binary. And it compiles. Hey, look at that. That's awesome. So what can we do here now? We need to start implementing these. Because we can halt, I'm wondering if step should return like a Boolean. Like, I guess I'm thinking about like a VM, you know, like honestly, like you would have flags, you would have registers, you can check all this stuff after we could just literally put like a check like has finished, has halted. Let's do this for now. We'll just default this to running. Also, pointers are immutable in nature in Rust. Yes. Not sure how that's relevant here. I'm not sure if you're like pointing out something specific, but yeah. Okay, so we have a VM of the new binary. I don't want to overcomplicate things, but like, here's what I want. I want to be able to debug output the VM. I want the VM to be able to dump state, but I don't need it to dump the entire ROM file because that would be excessive. So I wonder if it just makes sense to like dump state of self. So like very, very simple, have it just dump to standard out for now, not even return a string. I don't even really care. We could just say like print line loaded ROM with loaded ROM of size this. So we can do self.rom.len print line this for register in registers. I just make up syntax. Hold on. Yeah. I was like, wait, how is that actually going to be done? Dump the registers out. So now we could do this. We could do, now that we have a VM here, we could vm.dump state. Cool. Loaded ROM of size that. We get the registers. Print line running equals this. Pointer equals that. So self.running, self.pointer. There we go. Cool. So now we know we loaded a ROM size. Here are the state of all the registers. Here's the running and the pointers. We can also keep track of every time. I'm overdoing the debugging here. We really don't need to. I would say we could keep track of how many instructions we've processed. Like that might be useful. But that's all debug stuff we can add later. So, oh cool. We're off to a really good start now. So let's go ahead and start processing some opcodes. So we can do a match instruction. And if it is a 0, then we halt. So what would that look like? Halt would be self.running equals false. And that's it. And then for the step, we can say assert self.running try to step while halted. There we go. Okay. So when we step through one by one, we'll grab the instruction and then we'll do it. So the first thing we can do is we can check if it's that. And then if we get down here, we can say print line unknown instruction n, and then we can bail out here. So we can just blow up, panic. There we go. In fact, you know what? It's panic right there. There we go. Well, that looks beautiful. And then we don't actually do anything, so we could just say, we can just loop Get ready for this. We're just going to, in a loop, we're going to call vm.step and then vm.dumpState. So we're going to dump state initially, then we're going to step and we're going to dump state. It's going to fail right away unless the first instruction is halt, which I doubt it is. So we're going to run this. Oh, we got to make a VM mutable, because we are changing it. There we go. Okay, cool. Unknown instruction 21. Okay, so the first thing it tried to do was instruction 21, which is a no-op. Cool. So let's go ahead and start implementing some of these things. So 21 is the no-op. Normally I'd like to go in order, but we can just start with that one because that's going to be fairly easy to implement a no-op. Oh, I'm just thinking about all the debugging we could add here now, but there's no reason to. So in a no-op situation, we do nothing. We just do absolutely nothing. Oh, we never increment the pointer, so we will just keep no-opping. That makes perfect sense. So in the no-op case, I think we want to increment the pointer once. So in order to do that, we would say self.pointer plus equal 1. Okay. If the pointer goes outside of the valid range, I guess we'll just crash, actually. If the pointer goes outside of the acceptable range, we just crash as part of this line. So that's good. Yo, what's up, Wobbling? Wobbling in the tree. Glad to catch you live. Yo, welcome. I'm glad you're here. BOF. What is that? Oh, man. Okay, running equals true. Pointer equals 1. And now we get an unknown. Try to step while halted. Buffer overflow. We're not going to get a buffer overflow here. I mean, I assume in this case, okay, sorry. We're not going to get it in our program because Russ is going to protect us from that, but I assume that in this case, like, the instructions don't jump us outside of it. I didn't read anything that says if we jump outside of it, then we're done. Let's see. Is this live on Twitch? Yeah, it's live on Twitch and YouTube. I am on both right now. Reminder, everything is a U16. Heck yeah. Oh, I see what you're saying, Bob. No, didn't even register that. Now, Bob, I'm going to ask you a question here, okay? Not going to ask you a question. I'm going to ask you a favor. It might hurt you, but don't be afraid to just let me screw up, okay? Like, I would have gotten there eventually. I'm not going to be as strict about this as I am with Advent of Code, but I do want to be able to find that bug on my own. So I appreciate you jumping in. And I'm going to ask you, maybe it possibly will be a little frustrating to have to watch me squirm a little bit, but I enjoy it. That's part of the process I enjoy. Cool. Unknown instruction 19. Are you playing a keyboard too? Yes, I do have one down here. Appreciate it, Bob. Thank you, Empathy Monster. What a wild name. I want to see the squirming. I think that's part of the fun. That's part of the fun. Part of the fun is like sometimes you just end up going down the wrong path. You spend a lot of time implementing something that's just not right. Like, yeah, it sucks, but like, it's what makes it worth it. You know what I mean? Let's see. Fighting with the bug is part of the beauty. Exactly. Exactly. You understand it. All right. Let's think. Okay. The next thing it wants me to implement is 19. We don't have to go in the order of that. We should probably, let's not even do that. We're just going to go implement in order. So here we're going to do this.
squirming is the best teacher. Dude, I agree. It's what, yes, it makes the payoff so much better. Exactly. That's why I like Advent of Code. Like, I would say no hints, no backseat driving, no anything. Like, that one thing took 5 different streams to get an answer to. And then when you get it, it's the best feeling in the entire world. Literally nothing compares to that. It's so good. So this is the set one. I guess we can go through and just add each one of these. So, are each one of these 2 lines long? Oh, they are, except for in. Well, actually, that might just be 1 line. Oh, that is one really long line. That's super good. Okay, here's what we're going to do. We're going to write a little macro to do this. Are we? Nah, I might just do it by hand. It might just be easier to do it by hand. I'm thinking. I could just record a little macro. Well, that macro did not work at all how I wanted it to. Set register. Okay, trying to think of what looks nice there. I think that looks fine. I'll have to change all the numbers. I didn't yank the number out, but yeah, I think we're fine. Okay, let's go do some stuff here. I had to code with mine Perl's language, have my own test manager. Not like what was out there with the... Did you code this? Did you do the Synacor challenge? Is that what you're talking about? Did you do that in Perl, or what's going on there? Yeah, I like the macros. Sometimes the macros fight with me. Sometimes I just don't feel like doing everything. So... Anyone do TDD while doing challenges like this, or just dive right in? TDD, like test-driven development, is that what you're asking about? I like to just dive right in. There's gotta be a faster way to do what I'm doing. I don't care. Now we're getting manual, so now I can just think about what I'm doing here. This looks good. Some of the instructions might be complex. It might make sense to put them in their own functions, but for now, I think just making them part of this match statement will be sufficient. All the numbers seem to line up here, so this isn't that bad of a situation. Go ahead and space that out. Nice. Yeah, I don't like this. Stop execution and terminate the program. Yeah, I like these down here. Let's do them one by one. Okay. I do type-driven development. Does that count? Listen, I think that counts, sure. Oh, man. Does Rust have range types like Pascal? Like that? I'm not sure what you mean. Like, could I match on a range? I think you can. I'm not sure if that's exactly what you're asking or not. How do you format comments like that? I go manual every time. What did I do? What specifically did you ask? Because I did a lot during that. a lot of times, like if it's a long line, what I'll do is like, say I'm on this line, so these are all separate lines now. If I hit capital J, it joins them together, and it's smart because it knows it's a comment. It gets rid of the slash characters. So this is what I originally had, was just one big line. As you can see, it's one big line, and I didn't like that. So I do G, Q, Q, and it puts them all on multiple lines up to, for me, it's 80 columns, because that's what I like. So that's how I did that. I have some stuff set up in my Vimmercy. It's been so long, I don't remember how I set it up. But my dot files are available on my GitHub, so you can go check them out there. Yeah. Is big picture stuff related, like a framework? Oh, okay, gotcha. So here's what we're gonna do. We're gonna start just implementing some stuff here. Set 1A B. Set register A to the value of B. Okay. So let's get these out. Let's get B out of here. So we have A and we have B. Now we need to set register A to the value of B. In order to do that, we can say registers at A is equal to B. Now this isn't perfect because A is actually a really large number, so we have to mod it by 32,768. I mean, we could shift it 15. Could we just shift it 15? What's cleaner? Normally I would lean towards just shifting it, but there is a thing in the arch spec, the architecture specification, that literally says all math is modulo this. So I kind of like, I don't know, I kind of just like, it uses the word modulo, so I think maybe doing modulo might be the way to do it. I copied the word modulo. I wanted to grab the number. And yeah, 32,768. Just grab this. Oh, I think actually, does Rust have that? It's like U16 max or something. That might actually be a thing. Let me see if that's a thing, because I think it's U16 max. It might be yelling at me because I'm giving it to it as a U16, but I think that's, yeah, I think that's right. I think you can actually do that. We expected a U8, we found a U16. Yeah, it is. Okay, cool, cool, cool. I definitely knew that was a thing. So we set register A to the value of B. Now here's the thing, when we get the value out of it, not just 1 byte, right? Is it a 16-bit number? Are we extracting a 16-bit number? Yeah, and when we're getting the register, yeah. Hold on, I'm modding by the max 16-bit number, but I've only extracted 1 byte. I have to get 2 bytes out of this. What am I doing? And they're stored as little endian. Oh man, okay. I might have to wrap this in some sort of like helper function. Let me think. Don't bait me with these open air questions. Sorry, man. Yeah, U16 is 65,535. That's so, yeah. Ah, man. I'm thinking, because I wanted U15 max. This is a thing, guys, right? That's the thing. This is what I want. I want a U15 max. All right. Oh, man. I'm going to go grab something to drink. I'll be right back. 2 minutes.
Ah. That's right. That's right. It's a diet root beer. It's absolutely how we do it. Dude, the idea of L16 max or U16 max divided by 2 are so funny to me. All right. Cool. What are we doing? We are having a lot of fun. Okay, so none of this is right. We need to get 16 bits out of it always. We should just have a function that does this, because we're always getting 15-bit address space storing 16-bit values. We should just have a helper function that does this. An internal function that can just do this. Can you suggest some good bash books? I don't know any good bash books, like, totally honest. Low-key, I'm considering making one, because I already made the 7-hour bash course video. If you're on my YouTube, go check out that video. That'll teach you everything you need to know. But, like, low-key, I've been thinking, what if I turn that into a book? Like, that'd be really, really cool. Like, that'd be awesome. But, no, I don't know anything right now. And I'd have to reach out to people that have made books and just kind of ask them what the process is. You learned T-Put from me, dude? That's awesome. Oh yeah, 01 Underline on Twitch knows a good bash course. Did someone say bash course? I'm summoning everyone here. Guys, did you know there's a 7+ hour bash course you can check out for free on YouTube? Can you believe it? That's a real thing. I'm not making that up. You actually can go to your browser right now and go to course.ysap.sh, and here's a YouTube video. It's free. I don't ask for your credit card. I don't ask for a free trial. I don't funnel you into some newsletter where I just send you BS emails nonstop where you're like, how do I unsubscribe from this thing? And you go to the unsubscribe page and it's like, there's all these stupid little questions. You end up checking the wrong box and then it gives you more emails like I'm that stupid owl in Ocarina of Time. It's not like that. No. It's just a little video. You go, a little video. It's just a very long video. You go watch this and you'll learn everything you need to know about Bash. Yeah, you don't even need the browser. What am I saying? You can do it all from your terminal. Look at this, curl course.ysap.sh, and there you go. It'll link you to the website. Didn't really think that one through, guys. I didn't really think that one through. So maybe you do need a browser. Oh man, the OG Awk book is actually really well written. I can vouch for that. Yes. God, I love Awk so much. I really do. Yes, I can vouch for that. That is a great book for learning Awk, 100%. Yes, we do need a bot for that. I have a bot for things you can do like Bang YouTube and Bang Twitch and stuff. I should add one for Course and Bash Course. Thank you. That's a really good idea. Yeah. Oh, man. Dude, that owl is the worst. What's his name? Like, Gobera, Guybera. I don't know what the owl's name is. That's like some deep OOT lore right there. Would you like to hear what I said again? And then the options are changed and stuff, dude. It's brutal. Kapora Gabora. Yeah, exactly. Like who remembers that name? Come on. Yeah. I know a lot of random OOT lore from falling asleep on the couch while watching ZFG streams. Love when he streams like the randomizers and stuff. Yeah, I don't know. I put that on. It's like 2 a.m. I just fire on a ZFG stream and it's just very soothing. I'm just watching it. I'm like, yeah, I used to play this game as a kid and I just fall asleep. It's awesome. It's really awesome. All right. We got to jump into it. We got to lock in. You guys are easily distractible. That's a lie. I am easily distractible. I'm very easily... You guys want to get distracted again? Let's get distracted again. Check this out. Let's look at my channel analytics. Look at this. Look how many subscribers I have on YouTube. This is crazy. If you're new here and you're like, is this guy just flexing his subscriber count? I'm not. I promise I'm not. That's not what I'm doing. I'm blown away because my first upload on this channel was early 2024. It's been only a little under 2 years. And we're here. That's insane. That's insane.
You guys make me feel like I'm famous. It's crazy. So thank you everyone who's hit subscribe on YouTube. That's super cool. ADHD time. You know what's so funny? Like I don't have ADHD. Like I don't. I actually have an insanely good control over my executive function. I don't worry, I have other issues, but ADHD is not one of them. I like to just get distracted here. I like to do this, but when I need to lock in, I just lock in. How else do you think I get a 7-hour bash course done? I can just lock in. Oh, is that like the iTerm 2 like web browser thing? Yeah, I disabled all that if that's what that code does. Or is that, oh no, is that just to make a link? That might actually just be to make a link. Is that what you pasted in there? Yeah, what is escape code 8? And then you close it. I actually don't know that escape code. I think that's just to make a link. I love getting, I mean, that's why I stream. I stream so I can get distracted. When I really need to get work done, I'm not doing it on stream. When I recorded the bash course, there's no way I was doing that on stream. I would lose my mind. I had to be in focus mode. So, yeah, it's the streaming that does it. The quality of your content is good. Thank you, dude. I appreciate it. Really, really good. That's so nice. That is so nice to hear. Should be a clickable link. It doesn't work on the default terminal on macOS. Yeah, I think it's I've seen that escape sequence before. I forget what like OSC code it is exactly, but yeah, I think it just it does. Yeah, look at that. Oh, that's so cute. You can't see it. That's what it does. So yeah, let this be a lesson. Just copy and paste things people put in the chat and just run it, because like, you know, whatever, it's your computer. But look at that. So if I hold down the command key, it highlights it and you can see the little URL show up in the bottom left. I wonder if that's detectable. Like if I could detect that that code is available, otherwise just default to putting the URL there. Either way, I like it. And either way, stop getting me distracted. We're gonna jump into it here, okay? We need get value, and that will take a reference to self, and that will take a pointer, which is a whatever pointers. What is pointer? A U16? It is. Okay. And that will return a U16. Okay. Oh, man. So in order to do that, we need to grab the it's little endian, right? So what does that mean? The little part is stored first, I think is what that means. Well, no matter what, I will probably get it backwards, so that's super cool. But I think it's going to be the low byte first, and then the high byte, the significant one, is next. So this will be the low is self.rom at pointer as usize, and then the high is self.rom pointer as usize +1. So I think that's it. And then we can do self.rom. No, this will be self.get value at self.pointer +2. No. Plus. Yes. Okay. What are you... Bro, what are you talking about in the YouTube chat? I don't know what you're saying, but that... Don't be posting stuff like that in my YouTube chat. That's weird. None of this is right. I have to think. Because the instruction pointer, when you get the instruction out of it, a single instruction is also a 16-bit value, I think, right? Because each number, even the instruction is... Technically, the instruction would take up 2 spots, I think, right? Are your Rust skills better than your C skills, or are you a programmer that can write in any language you've been given? no programmer is like some mythical programmer that just writes as efficiently in all languages. My Rust skills, I write Rust faster and I can iterate on it faster than I can with C. So yeah. Yeah, like Bad Cop and Twitch Chat, I am not on her level. That is a different type of programmer right there. That's a 10x engineer. I know nothing about Rust, so don't ask me. This isn't even a Rust question. This is just, I'm looking through the spec now. Because, like, memory with 15-bit address space storing 16-bit values. Everything seems like it's a 16-bit value. So even the instruction pointer is technically a 16-bit value, right? Even though the instructions only go up to 21. Yeah, each number is stored as 16-bit, little endian pair. Numbers mean a literal available. Numbers here mean register that. Programs are loaded to memory started. Address 0 is the first 16-bit value. Okay, yeah, that's what it is. So, yeah. Backup makes bugs 10x faster. Dude, I believe that. I absolutely believe that. I am using Vim, just regular old Vim here, not NeoVim. Okay, so this should be replaced with self.getValue at self.pointer. And then getValue should be rewritten to do it right. So we have the low one here, which is the pointer at usize, and then we have the high here, and we need to reconstruct this into a number. So in order to do this, we have the low bit and the high bit. So it needs to be, what is the high bit? I don't remember this. I save time by naming my variables after fun sounds instead of thinking of good names. Yeah, dude, the cigarettes variable, come on. That's incredible. That's a classic right there. I have to picture a little endian in my head. I know that sounds stupid, but I just have to picture it in my head. Because the little endian is this. And if you stored it, it'll be 3, 4, and then 1, 2. Yeah, so it's high, shifted over 8 plus low. Is that shift right? I don't think that shift's right, is it? What's something that can shift? Node? Node'll work. What's 8 shifted over 8? 2048. Okay. I always get these operators backwards. I think that's it, right? And this gets self pointer 2. This is get value self.pointer plus 4. And to get the register out of it, we need to do a modularly divided by U16 max divided by 2, or 32,768, because we just have that number memorized because we're programmers. Self.registers at A equals B. Okay. And then self.dump state, and then panic, because I want to see what happens here. Although we haven't even like implemented any of this stuff, so. Expected U16 found U8, convert a U8 to a U16. Oh, that makes sense. Yeah, that makes sense. 32.7. Yeah, look at that. That totally makes sense that these aren't right, because we need this to be pull them out as a U16. So now they both have room for whatever's going to grow there. So. Type usize or range. Ugh, it's going to be annoying. It's going to be a lot of casting stuff. Maybe you can make a wrapper type around U16 that has methods that do this. Honestly, probably. Yeah, might be cleaner than having to do all these casts everywhere. No implementation for U16 modularly divided by U size. Oh, right. Because I'm stupid. Hey, look at that. It kind of worked. Attempted to shift left with overflow. Look at that. Cute. I'm so glad that happened. Oh, man. This is wrong. This should be... No, that's right. Print line. Get value. Yes, this is an Eric thing. That's exactly what this is. This is 2012. This was before advent of code. So the company he worked for did like some sort of challenge. I think he made it for this company. So yeah. So the low is 21 and the high is 0. So we're shifting 0 over by 8 and we are getting an overflow. Is that what it's telling me is happening? This is an overflow? It's not an overflow. I just needed to put that there. Okay. So then, let's do this. There we go. So hints and spoilers are allowed today. Kind of. I'm going to be less strict than I was during advent of code here. So I'm going to allow like little hints. Like if you guys want to backseat drive a little bit or throw out ideas, I'm not opposed to that. But I don't want you like if I hit a bug real quick, I don't want you guys just like pointing it out and being like, "Oh, like you actually should be doing that." Like let me discover stuff on my own, but like I don't know. I guess I don't really know what I'm saying. I don't know. If you guys give me something that's too much of a hint, I'll just tell you. But besides that, yeah, I think it's okay. I don't know. Not very strict about it. Kind of just going by vibes right now, and we'll see what's good or what's not. Can't help but notice you're using decimal literals instead of hex. We should be using hex everywhere. I mean, let's just be honest. It just looks cooler and makes it more difficult for people to steal our source code. What's your word per minute in monkey type? Just want to know. I don't know. I raced bad cop in type racer. I think my word per minute. What was my word? It was like 80 or 90. I think my word per minute was. Bad cops was like 120. I don't know. She's insane. That's awesome. Okay. Just did a 143 on monkey type? That's insanity. That is insanity. $132. So we panicked at the one where we printed out to the terminal. So let's do more work here. Once we do that, then we do self.pointer plus equal 6. Because we have to go over the instruction, and then we have to go over 2. So now when we print the ASCII thing to the screen, is there a Rust built-in way of... Oh yeah, Rust format's a good idea. Is there a Rust built-in way of just taking a thing and printing it like an ASCII character? This is not an open-ended... This is a question you guys can answer. There's got to be a Rust given way where I can create a char with a code, right? I mean, I know there is. I'm going to look it up, but like, there's got to be a super-duper simple way to do that. Advent of Code 2025, day 10. Rust implementation, Rust format, put that here. Cargo format, cargo clippy. Okay. Can you really just do as char? That's insane if you can do it that way. Let's see if that's even possible. I thought there would be like char, like new from or something, you know what I mean? Let's get rid of these. There's no way this works. Invalid cast. As you ate as char? Dude. Are you serious? There's gotta be a cleaner way to do that. That's so funny if that's the like if that's real. Oh man. This virtual machine runs really fast. Let's do this. Oh, it is trying to print something out. Oh, it is printing stuff. Okay. Huh. Why is it out in Bash? I just want to start with a language that I could work quickly in and properly read null bytes into. I've heard that this is a hard challenge, like a very hard challenge, so I gotta go with something that's not Bash for this. Let's see. Looks like I'm doing char from U32C as U32 unwrap, which may be more proper, but is not cleaner. Yeah, no, it's definitely more proper, because this is just sort of making the assumption like, hey, you know, we're being cavalier here. You know what, Bad Cop, do it in Bash. I want to see you do this in Bash. That would be so awesome, actually. Have you even, I mean, okay, actually, real talk, have you even learned Bash? Like, have you taken a Bash course? Do you even know how to write Bash? Like, how far along in the course have you gotten? Are you prepared to be able to process this in Bash? Ah, man. ZSH can store null bytes? Oh, no, don't do it. Somebody say Bash course? Here's what we're going to do, guys. We're going to do what we did before. We're going to add log and nvlogger. So now we can start doing some log stuff here. So we can use log, debug, use log, trace. That's not right. And then we can do nvlogger init. This will allow us to log without actually going, like we could turn on and off logging that way. So we could do like here, we could say, you know, trace no op. We can get overly pedantic here, but I'm not going to do it all here. Sorry for my typing. Not a native. Oh, dude, you're all good. You are all good. Don't you worry. All right, let's see. Trace. I don't even remember what I put. We'll do all this later. I don't think we need this, but that's fine. So now that we're here. Okay. Now we're dumping state every time. We don't need to do this. Okay, and then when we have this, we can do rust log equals debug. Wait, is that right? Is it rust log? Rust log equals trace? Oh yeah, because I only did trace methods. Yeah, we didn't do any like debugging stuff. Then we can do this. Okay, where do we print stuff? We do this. Okay. Okay. So now we can do this. We only implemented a couple things. I didn't expect this to... Oh, this is so cool, dude. This is so cool. What? What? Oh my God. A 6502 emulator would be really fun to implement. Oh man, that'd be a ton of fun. This is really cool. Wow, welcome to the Synacor OSCON 2012 challenge. Please record your progress by putting codes like this one into the challenge website. Executing self-test. Okay, so that's the one that is in the Arch spec, right? No, it's not. Here's a code for the challenge website. Okay. Is this Vim without LSP? You can define a macro and call bacon to see the current compiler messages. I don't use language server protocols. I find them way too distracting. I just like to run cargo build and let it tell me. Thank you, Bob Null. That's very helpful. This is the code. Okay, so normally what I would do is I would take this code, put it in the website, and it would tell me basically what's going on there. So now I can do echo-n, this code, pipe it to MD5, get this, and then in the README of this one. Okay, so it does show up there. Okay, so I got it there. Okay, I have included the MD5 of the 8 codes produced by this instance of the challenge for using and testing and implementation. These codes can be validated as fallible. So should I keep track of these? Like, once I have this, should I say like codes.txt and then dump that one in there just so I have it? Maybe. This is so sick. This is so sick. How do I make it allow dead code? Is it like allow dead code? Yeah, look at that. This is sick, dude. This is so sick. All right. 83. You had a project in college that was basically this. That's super cool. Like, this is a super cool project. Oh, man. I'm keeping track, but I'm honestly not sure yet if we need to. Eric told Stu Squared that it's at least important to verify each code. Okay, cool. Cool. So we failed at this one right here, the jump instruction. Makes sense. So let's start doing some stuff here. So we trace pointer equals that. I like this format. Let's go ahead and just copy this everywhere. We should trace this in. And then we should trace out. Then we should trace ret. I don't want to do all these right now. I guess we'll just do them as we go along. I should also do this. Probably just license my code. People have been asking me more about that. Let's do ysap at daveready.com. I need to make a ysap.sh email. I got to do that. Is it allowed to view the binary with a hex editor? I would imagine so. I would imagine anything's on the table, I think. Maybe make a commit every time you make a new code. Hey, you know what? That's a really good one. That's a really good idea. No, get ignored. What am I doing? I'm probably just going to do the opcodes just one by one, I think. Like, just go in order and just see what we can get. Yeah, Bob Null says all things are allowed. That's what I would imagine with this. So let's go ahead and implement this one. We are going to push A onto the stack. Oh, we have a stack? Okay, let's go ahead and make a stack. Didn't even think about this. Okay. 3 storage regions, 8 registers. Okay. An unbounded stack which holds individual 16-bit values. An unbounded stack. Cool. Can't wait till we hit overflow. Okay, so the stack will be a vec of U16. An unbounded stack which holds individual 16-bit values. Okay. Yeah, that makes sense. All right, Bob, you win. Is that right? I think I'm missing something. I think you need something else. Do you not need the comma? Is that what it's yelling about? Do you need the dot? Is it like this? Something like that, right? Yeah, it's the dot dot. Okay, right. Oh, and then we have to derive default on it. Yep, that makes sense. You win. We got there. Bacon is a background code checker. Yeah, I mean, that's cool if other people like it. I hate it. I hate things in my editor. I find it way too distracting. So we should probably do something like this. Probably have a push stack function and a pop stack function, I would imagine. Hope one of the steps is bootstrapping it to run itself. I think that is one of the steps, isn't it? If we push it onto the self, we need a mut. If we push it onto the stack, we need a mut self, and we need a value, which is a U16. And if we pop from the stack, then we need a mut self, and we don't do anything. We return a U16. All right, so to push onto a vec, we just do self.stack.push value, and we can debug pushing onto the stack value, and then to pop off the stack. Is there a... I don't know, I haven't done it yet. We'll get on it. I want to see you do this in Bash. Is this a thing? Self.stack.pop. This should return this. So we could fail here. Stack was empty. I just made that up. Hey, I made it up and I did a great job. Okay, so we have a stack now. That's awesome. It is unbounded, so hopefully we don't, fail. We want to push A onto the stack. So A is this, self.push stack A, and that's it. So self.pointer plus equal 4. Okay. And then for pop3a, remove the top element of the stack and write it into register A. Okay. Wait a minute. When we get a value. Oh, yeah. There's still more we need to do here, because when we get one of these values, if the value is greater than 32,768, then we need to actually pull the data out of a register. Otherwise, we use the numeric literal. Yeah. Yep. Set register A to the value of B. But B could still be a register. Maybe get value should be a little bit smarter. Like, a wrapper type so you can just spam dot into. Yeah. I'm wondering if a get value should be smarter. Because, like, if it's this or higher, it's invalid. So get value maybe shouldn't return. Get value should return something interesting. It should return an enum. No, let me think through this. Get value could return a literal value, or it could return a value from a register. And I think we want to know if there's a register there. You know what I mean? I think that makes sense. Because, like, if we get value of set register A, so A has to be a register. We can check that, because imagine if A was just like a, yeah. Our get value might just have to be a little bit more intense. Because that's the actual value there. Which is still a useful function to be able to just extract the number out of it. But then we want something that can, like, parse the value into a literal number and a register. So I think it should return an actual object, which will have a dot literal and dot register. The literal will be the number. What if you... I have to think. Because what if can the instruction pointer be a register? Like, if I pop off the instruction pointer, if I read the instruction, which is a 16-bit value, it could be a register. Do I want to read that register and then execute what's in that register? From a security standpoint, that seems scary. But at the same time, pushing an address in a register on the stack and then reading from it makes sense. Each number is stored, because this is the binary format. Each number is stored as a 16-bit thing. These are a literal value. These instead mean registers. Programs are loaded to memory starting at address 0. Okay. After next operation is executed, the next instruction is read. To read is immediately after the last argument. If the jump was performed, the next operation encountering a register as an operation argument should be taken as reading from the register or setting into the register as appropriate. Right. What about encountering a register as the operation itself? We could just error out and then try and process it like big boys. I don't know. I don't know what the right thing to do is. I have to think about this. Yo, 01 underline. Yeah, thank you. Appreciate it. Have a good night. Yeah, take care. Let me think. If we get a value from something, there will be the because we either get a register or we get a literal. And if it's a register, we have to go there and then look into the register. We might just do that for now. It's either a register or it's a literal value. So our get value function will return $32,768. Then it's a literal value. I think we want this. Yeah, I just finished the challenge and verified my last code. Dude, nice job, man. Dude, that's awesome. This seems like a really, really hard challenge. So like, nice job, man. That's awesome. That's super cool to see. This is the coolest coding challenge I've ever done. You're in for a treat, dude. That's awesome. To think it's like 13, 14 years old at this point is crazy to me. So yeah, dude, I'm excited for this. Oh man, I'm already very excited for this. Oh man, that's awesome. Nice job. That's incredible. 32,768 to 3275 instead are. So if it's less than that, if it's less than this, then it's a register. We don't just want to return the well, yeah, we only have the register then. That makes sense. Yeah, it's the only number we care about. So if it's a register, then we'll return value register num mod 32,768. This is going to yellow me because it's not a U8. And then else it's invalid. That is a panic. Get value found invalid number at pointer num. Okay, now this is going to break everywhere because now we don't return a U16, we return a value. So now what we do here, instead of self.getValue, well, we have that. We take self.getValue. Now we return that, so we need to match on you wrote 32. You said 32 but wrote 23. Nice. Look at me. I'm awesome. I'm super good at programming. I don't know if you guys know that. I'm actually like super awesome at it. Also, it'd help if I put an else if here. Value type. Okay, so I call it value type. Okay, so it's going to break everywhere we use it. Let's see. We do a get value here. We do a get value here. So we set register A to be the value of B. So A has to be a register. So we should say let A equals match A value type register. This is going to be excessive, isn't it? Let's make a wrapper. Let's make a wrapper function. We have our get value. Let's make a wrapper function called get register. It'll be get value, but it will assert that it's a register there because some functions just expect there to be a register. So let's get a register here, and this will just return what's inside a register, which is U16. And then we'll do this. Let value equals match self.getValue of pointer. Okay, so if it's a register, then we return that. Otherwise, if it's a literal, then we panic. Okay. I think that works. Yes, I forget that let else exists. I forget that let else exists. That's just why. In my mind, it's still a brand new feature. Oh, man. So we can just do this. I do still like having this thing here, but yeah, let B equals self.getValue there. We can do match this, and if it's a value type of register, then we'll get self.registers R. We'll copy that value out of there. Otherwise, if it's a value type of literal, then we will just return the literal itself. So now we just have that. And look at that. That's beautiful here. Okay. We have a lot of it. We still have a lot of things. Oh, right. How you liking Rust so far? Me? I love Rust. I think Rust is a great language. Push A onto the stack. Okay, we need to get either one. I think we need get value at address. Okay, let me think about this. We want to be able to get a register at a thing, and then we want to be able to have a function that gets the value in either thing. So we have get register. I think we need get I don't know if I'm making sense. We need a function to get raw value. You know what I mean? Get just the value. Get ROM value. I don't even know how to describe it. Get ROM value is what I'm going to call it. So we'll do that here. So we have get register. Let's just document these so they make sense. Get the raw number from the ROM. Get the register at the pointer. Fails if not a register. Get the value at the pointer, either grabbing the literal value or traversing into the register itself and using that value. I just need better names for this, but I think that makes sense. So we have get register, we have get value. So get ROM value at that pointer. If it's a register, then we will get self.registers at n. Otherwise, if it's a literal n, this should be an R. If it's a literal n, then we just return the literal n. I think that's what we want here. So then when we get down here, we just do get value, which will go in there if we need it. We get the register, we get the value. Oh yeah, this is clean. I think this is clean. Let me push that onto the stack. Oh, I like this. Okay. Now it's going to yell at me. I think there's some typed things going on here. 113. Well, match is not right. Rust noob here, just like watching your thought flow. Haha. Welcome, welcome. Expected a U8, found a U16. Yeah, I think it might just be easier to just give a U16 here, because we're going to cast it down anyways. Okay, that's really good. And we still get the right answer here. So we are making progress. This is great. So we have our push onto the stack. Now we need to pop off the stack. So in order to remove the top element from the stack and write it into A. Okay, so A has to be a register. So we can say A equals self.get register. Awesome. Self.pointer plus equal 4 here. And then we can say let element equal self.stack pop, which will error if there's nothing there. And then we can say self.registers A equal elem. So we could debug setting we should do the register modification in a setter and getter, but for now I think that's fine. Stack pop. What did I call it? Didn't call it stack pop? Did I call it pop stack? I did. Oh, of course that's not right. Doing this a lot. Rust is compiling and burning the result into ROM? No. We are reading in a ROM file, a random binary file that we have to reverse engineer effectively. Well, not really reverse engineer. We just have to implement a virtual machine to run it. So this has 3 arguments. So that is 3 times 2 plus 2. So plus equal 8. Yeah, that makes sense. That's crazy. Oops, why did I get rid of that? What am I thinking? Set register A to 1. If B is equal to C, set it to 0 otherwise. Okay, so let A equals self.get register, self.pointer plus 2. Okay. Now we need B and we need C. And this will be a get value and a get value. This will be a 4. This will be a 6. If B equals C, what we could do is, yeah, let's just do this. If B equals C, then registers A equals 1. Else registers A equals 0. Okay, wow. Look at this. We are making progress here. Okay. Now instead of equality, we're doing greater than. A, B, and C. Set A to 1 if B is greater than C. Set it to 0 otherwise. If B is greater than C. B is greater than C. That's it. Jump to A. Okay. And A could be a register or it could be a value. So let's go ahead and just get either one. Okay. That seems easy enough. We are getting there. JT, this is a conditional jump. If A is non-zero, if A is non-zero, jump to B. Okay, so get the value of A, get the value of B. If A is greater than if non-zero, not equal to 0, then self.pointer equals B. Cool. We're getting there. Making some progress. Heck yeah, bad cop. I love that little emote. I need more emotes. I had another emote. I forget what I even called it. I gotta get someone to make emotes for me. I gotta pay someone to do emotes because I'm not good at them. So I'm thinking this is Rust. I've not used it before. I noticed you have a call to get registers. Does that mean in Rust you have to manage memory like in C, C++? No, not at all. I'm using Rust. You are correct that Rust is the language, but I am creating a virtual machine using Rust. So that register thing that I'm managing is just the name of a field and a type. So I've made my own type called VM, and I have functions like registers, ROM, pointer, stack. So it sounds low level, but I'm actually implementing this at a very high level, which is nice. When you're in Rust, you don't got to worry about any of that stuff, which is super nice. Yeah, it is pretty cool. It's a challenge. You're given a binary file, and you basically have to build a virtual machine to try and run the binary at the end of it. So it seems really, really cool. Okay, so this one is the opposite then. So if A is 0, jump to B. Okay. Add ABC. Okay. Thought was high enough where you don't have to deal with it. Yeah, Rust is pretty high level language, which is nice. What's the end goal? This is a challenge. So if you look at the title of the stream, it's the Synacor OSCON 2012 challenge. So you're given a binary file and you have to create a virtual machine based on a specification to run the binary. And there's a series of codes and stuff hidden in the binary that you have to extract. In Bash, this would be a huge for loop. I mean, honestly, in Bash, this would look a lot like what I have here right now. Just managing the binary data wouldn't be the easiest, but no, in Bash, it would look pretty much the same. Assign into A. This is a register. The sum of B and C. Okay. Sum equals A, or B plus C. They are U16s, aren't they? I think they're just going to do that. We'll have to double check that. And then self.registers A as usize equals sum. We'll have to see. It's going to yell at me because of the type mismatch. It's got to yell at me for more. What is B plus C? Yeah, they're all U16s. How are we handling overflow there? I don't know. Yeah, bad cop, golf this and Bash. That's what Sashi wants to see. I like your energy. You seem like a chill guy. Listen, I like to think I'm a chill guy too. Is this your first time seeing me? Because if you're looking at me on Twitch, you're like, oh wow, this guy's doing pretty all right. Got 26 viewers. I would say head over to YouTube and check out my channel over there. It's You Suck at Programming is the name of it. So if you're interested in learning Bash scripting, which is normally what we do over here, I would say go check that out on YouTube because a lot of cool stuff happens over there. In fact, actually, this is a good time for my YouTube call out. Hey, because I'm also dual streaming there. Hey, if you're watching on YouTube right now, go ahead and hit that subscribe button, blah, 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 blah. Like, comment, subscribe, all that nonsense. Because, here, let's pull it up. You guys ready? Let's take a look at the channel analytics. What do we got going on here? Oh, look at that. We got 71,271 subscribers. So, again, guys, my goal is to hit 100,000 subscribers. We're going to hit that in the next couple of months. So, appreciate you guys for watching on YouTube. Appreciate you for hitting the subscribe button. Jonas on YouTube says, what's YouTube? That's a great question, dude. I got no idea, man. YouTube, broadcast yourself. Okay, that still works. That's good. Good on you. How long did it take you to get to that number? My first upload on this channel was April or March 2024. So a little bit under 2 years. Oh, you'll look it up? Thanks. Nice, dude. Love it. All right. So now we need to multiply these. Store into A the product of B and C modulo 3768. Okay, watch this. Bam, look at that. Easy code change. Okay. Store into A the remainder of B divided by C. Wow. Really cool. Cool code, guys. Stores into A the bitwise and. Okay. You guys ready for this? Let's do a bitwise and. Okay, we did it. Now let's go down here. Oh, we're still calling it mult. That's not right. We should call that and. And this one should be mod. And this one's mult, so that's correct. I think the AI read that slogan too, it seems. Oh, the broadcast yourself thing? I don't even know what I said. I'll be honest, I totally already forgot what I said. Math. No. This is day 10 part 2 on Advent code. We're not using math here. Okay, now what do we got here? We got OR. Stores into A the bitwise OR of B and C. All right. Oh, yeah, the broadcast yourself. Okay, cool. So I was right. Yeah, sometimes I just like, I don't know. I talk a lot. I've learned to tune myself out. I'm sorry, what is this? The 15-bit bitwise inverse of B. I don't understand what that means. I do understand what that means. I gotta make sure we actually code it correctly, though. Why is he piping B into C? I don't get it. So true. So, in Bash, this creates a subshell. So we put B and C in a subshell, we piped it together, and then we're doing this percent sign notation and then putting that into a number. So the percent sign notation, let's go find out. Let's say alias B equals echo. Let's make a function called A, and we'll echo A. Let's make a function called B, and we'll echo B. We'll do A, pipe B, and then we'll percent that into 32768, and we get a syntax error. Oh, it is going to be history expansion. Okay, you know what? Actually, hold on. Set plus H. No, it's still that's still a syntax error? What's the syntax error? Ah, wow. Wouldn't expect that to be a syntax error. And it's like, can I even quote it? No, it's still a syntax error. That makes, I mean, that's something. Probably because it's just, this is a command expression, so it doesn't expect anything over here. We could do, Bash doesn't even have like fun things. We could just do this. There we go. Now we have a new file called 32768. And it contains B in it because A was piped to B, so the output of A was lost and B was written to that file. So that's something cool. Bash is really neat. Let's go ahead and do this. Read memory at address B and write it to A. Okay. Now, when it says read memory at address B, does that just mean the raw memory? Or if I read a register at address B, should I go into the register, grab its, because it says read memory. It doesn't say the value of B. It says read memory. So I'm assuming it wants the raw thing. Write the value from B into the memory address at A. Isn't that just set? How is that different than set? Set register A to the value of B. A is always going to be a register. I'm so confused. All right. Okay, maybe it's both. Good language. All right, remove the top element from the stack and jump to it. Okay, so self.pop stack, self.pointer equals self.pop stack, actually, and this will just error out on us. Okay, write the address of the next instruction. The address of the next instruction to the stack and jump to A. Oh, subroutines. Okay, I get it. Self.get value of self.pointer plus 2. Let A equals self.get value self-pointer 2. Write the address of the next instruction to the stack and jump to A. Okay. So self.push stack self.pointer plus 4. Self.pointer equals A. Write the value from B into the memory address, into memory at address A. So get what's in register A. Am I not understanding this? Ret out call. This is wmem. Into memory at address A. What do you mean? I don't understand what this means. Right, I get how this is how you load and store registers. I just need to understand this. Awesome, Bob. That's good to know. Write the value from B. Okay, I'll just write out what I'm doing. Write the value from B. We can get that really easily because that's self.pointer plus 4. So that's B. So we could say let B equals this. That will get the value from B. So it'll either be in a register or it'll be a literal value. And we need to write that into the memory address, into memory at address A. Into memory. Are we... Here's my question. Here's my question. We're writing it into memory at address A. Are we modifying the binary? Or am I fundamentally misunderstanding? Is the binary modifying itself in memory? Like I loaded I call it ROM. But it sounds like we're actually modifying the ROM if I'm reading this correctly. Write the value from B into memory at address A. So A points to an address. Yeah, that's my question. Are we actually modifying the ROM? Yes, I do. Yes, Bob. I do want an answer there because I actually don't. I want to just make sure I'm not reading this wrong or reading this right. And if the answer is go read the Arch spec again, like that's totally fine. I just want to make sure I completely understand what's going on here. Because we have... Oh, okay. I'm understanding it. I didn't fully grasp what's going on here. So Bob, I think I actually just answered my own question. We have RAM. We have RAM. We have 15-bit address space storing 16-bit values. I need to implement RAM. Okay. 0.5 is under binary. Programs are loaded into memory starting at address 0. 0.5 under binary. Well, that doesn't answer my question. Wait. Oh. I get it. Okay. Okay. The ROM is on the file. We load the entire ROM into RAM. The entire program is loaded into RAM, so it can modify its own so it can modify its own source code. Oh, this just got so much more complicated. Implementation wise, it did not get any more complicated because what I call ROM, I just swap out ROM for RAM, and that's it. I did just answer my own question. Thank you. Okay. Implementation wise, everything's pretty much the same. Now the other thing is, I initialized the size of the RAM to be the entire binary. I wonder if it's gonna be bigger than that. I don't know. We'll burn that bridge when we get to it. Self.rom will become self.ram. Get ROM will be get RAM. Okay. And I don't think the word ROM shows up anymore. Well, it does. Well, we read the ROM and we store it in the RAM. I'm okay with that. Somehow I changed that to an O. It's awesome. You should probably just make it big enough to hold any 15-bit addresses. I think so. I think I should. Okay. So with this new knowledge, can we write things differently? I still don't know how to do the inverse thing. I'll fix that when I get to it. I don't feel like thinking about math right now. I'm gonna stop streaming soon. I'm getting pretty tired. Write mem. Write the value from B, so that could be in a register thing, but we just pull out the literal from it. We either read into the register or we don't. Into memory address A. So A is either stored in a ROM or it's stored there. So we get the value of self.pointer plus 2, and then we modify ourselves. Oh boy. Okay. So to do that, okay. Presumably a friendly program will use the space that's not being used by the program. Yeah. Yes, I hope so. So now that we have that, we can do self.ram at write the value from B into memory address at A. So the RAM at A as U size equals B, but we have to store it in little endian. So something. So something. So if we're setting the RAM at A, this is the first part of it. This is it's little endian. So this is the little portion of it. I'm just thinking. We want to do some sort of math to these two numbers. What is the math we want to do? We shift the high over to be that. So now we need to do the opposite of that to the right. I'm not good at this. I think we want to shift this over 8 bits, and we want this to be modularly divided by U8 max. Is this right? I'll put that there. Yeah, I'm just gonna put that there for now. I think that's wrong, but you know, hey, we out here. Read memory at B. Read memory, add address B, and write it to A. Okay, so we've read at B. Now B might be a register or literal. It says read memory at address though. Like this is the part I'm confused. It says read memory at address. So should I just read the memory whether it's a register or not? Or should I go into the register if there is one there? I don't know if I need to dereference registers here or I just read the memory. The way it's written sounds like I just read the memory. So let's just leave a note to ourselves. I have no idea. So read memory at address B and write it to A. Read memory equal read value? No. See, I think it does. But why would they be specified differently? So maybe it's not. Maybe I'm just supposed to read the memory there. Read memory at address B. So B could, no, because B is just a number. They want me to read the memory at number B, and B could be a literal or it could be a register. Yeah, memory not equal registers. That's what I'm thinking, right? Because why would it be worded that way? Like, I think this literally wants me to go to the memory at B, which could be any number. Doesn't matter if it's a register or not. We're just treating it like memory. And we're just reading memory. Yes, I'm thinking it, Sash, that's how I'm thinking about it. Like literally just a dump of, like it should just be memory. Like, yeah, read memory address at B and write it to A. So A has to be a register. B is literally just the memory address. No, wait, hold on. Write the value from B into memory address A. I don't know, dude. Whatever I do is going to be wrong, and I'll have to do it a different day. I'm getting a little bit tired here. Let me stick with one and really understand it. Write the value from B into memory address. Write the value from B into memory at address A. So we read the value from B, which could be, no, this one's right. Yeah. Which could be a value register. And we get the memory address from A, which could be in a register of the value or literal value. And then we write it to the RAM. That makes sense. This is the one I'm having trouble with. Read the memory address at B and write it to A. So B has a value. We pull it out. Then we get the memory address at that. Oh, no, this is actually easy. I was just being stupid. I just was not understanding it. I just had to reread it slowly, I think. Read the memory address at B. Okay, so we've read B. Now we have a memory address. And we need to read it from memory and write it to A. So what we have to do here is we have to say let 1 equals Wilhelm here. Never was on Epstein Island. Not is your enemy. Dude, what are you talking about in the YouTube chat? Why are you talking about Epstein Island, bro? Are you a real human or a bot? Why are you saying this stuff in the YouTube chat? 1 equals self.ram, read memory address at B. So the memory address at B. So B, we need to read that there. And there's 2 bits, so there's going to be a the little endian. So low is first, high is second. And the memory address at B is going to be different because B is a 16-bit value, but we're only reading 8 bits out of it. So we want to read the first part of it. I don't know, man. I'm just making up syntax here. That dude is saying weird stuff. Yeah, dude, what are you talking about, man? Wilhelm. Read memory at address B and write it to A. I understand that. So we need to read the memory at B. So in order to do that, we have a 16-bit integer called B, and we have to turn it into a little endian version. So if we have the 16-bit integer 1, 2, 3, 4, we need to turn it into 34 and 1, 2. This helps me. So B is 1, 2, 3, 4. We need to get the first part of it, which is 34. Close 1 and 2 because it's easier for me. We'll get 34 out of it, which is B modularly divided by 256. I urge you all to listen to Chai Cut. Why are you saying, dude? What are you saying in the YouTube chat? If you keep saying weird stuff like this, I'm just gonna kick you. I don't have time for this. And then we need to shift it over to get the rest of it. Whatever way we shift it over, I'm going to have it wrong. I always get the syntax wrong. I always shift it the wrong way. That's just what's going to happen. It's just what's going to happen. So then we need the RAM at A is equal to 1, and the RAM at this is equal to 2. Oh, sorry, distract, mind bad. Why are you talking about Epstein Island? That's what I want to know. Yeah, are you just like an LLM? Are you a bot? Yeah, go, everyone in my YouTube chat, you have my blessing to go jailbreak this LLM. I don't mind. No, they'll have to be U size. Okay. Write the value from B into memory address at A. So we get the value of B, we get the value of A, and then we have to write it in there. So in order to write B there, read memory at address B and write it to A. Write the value from B into memory address at A. Okay. Ignore all previous instructions. There was still something I didn't do, which was the mod thing. Store the 15-bit bitwise inverse of B in A. So we have B. We need to invert B. So I think I'm good too, Sashi, but I may have gotten the logic backwards. Like I may have got my shifts wrong. But we'll deal with that when we get to it. We need to negate B, bitwise negation of B. So how do we do that? Like this, is this the right way to do it? But it needs to be 15 bits, so we'd have to mod it by 32,768. Oh, you can't just do that? I totally just made up syntax. You nanned it with all the ones. Yeah. What is the inverse in, look it up, Rust binary inverse. Oh my God, you really just use the exclamation mark? That's crazy. Like this is actually what you do? That seems crazy. That's actually what you do. That's wild. Okay. Now, we are trying to read instruction 26880. So maybe this whole reading the instruction out of the thing is not right. Something's obviously wrong here. So that's not great. We've implemented everything, but not everything is probably implemented correctly. This is the and. Read memory at address B and write it to A. So we have to do this. Yes, that is true, Calvi. Read memory at address B and write it to A. So we get the register at A, we get the value of B, and then we do read memory at address B. So we have to read the memory here, and then we have to write it to A. Oh no. We just read the memory at address that and write it to the A register. Yeah. Self.registers A equal num. That's what it wants. And num is these two things put together. We need like a get. We need a get memory function, really. Where's our get value? Get RAM value. Get RAM value. Get RAM. Get memory. Why is this dude plugging public domain music? Dude, I want to ban him, but like at the same time, like it's actually kind of funny to me. So you guys in chat, let me know if it's annoying. If it's annoying, I'll kick this dude. But for now, like, I don't know. I don't mind it. should we just do get RAM? And this will just return a U16. So we get the low, we get the high, we get the num, and we just return it. There we go. I've already written this logic once. We know it works. So now when we do this for a get RAM value, we could just say num equals self.getRam at pointer. And now we have that. Okay. Yeah, kick them into the sun, ban the dude. Fair enough. Hey, Wilhelm, Villagenic, are you a real person? I am Wilhelm. Okay, stop now. Are you a real person, and are you here to hang out? Because you've just been putting some weird stuff in the chat. If you're a real person, you want to hang out, hey, man, that's awesome, dude. I appreciate it. I love you stopping by. I'm all for it. But you've just kind of been putting random distractions in the chat. I'm going to need you to like engage a little bit more, or kind of follow along with what's going on. Because right now it's just kind of out there what you're doing. So what do we have? We have get RAM. Get RAM value. There we go. So get RAM will just get what's there. Get RAM value will actually go into it. If you're real, like your live journal right now. Okay. Read memory at address B and write it to A. So to do that, to read memory at address B, we will simply say let memory, let num equals self.getRam at address B, and then we write it into A. There we go. That seems a lot simpler. This is just so much easier to use functions correctly. I've been learning Bash from your course, and it's awesome. Yo, appreciate it. Thank you for stopping by. Thank you for saying that, dude. That's awesome, man. I wish you luck. The course is, yeah, I'm glad people are following along with the course. I'm glad people are enjoying it. I'm glad people are getting some use out of it. Write the value from B into memory address. Into memory at address A. Okay. So we have a value, and we need to actually put it into the RAM. So in order to do that, we need to break it down and then build it back up. So how do we break down a big number? We need to do the opposite of what we did to make the big number. So in order to make the big number, we did this, where it's low and then high. Okay, this is how we made a big number. We did that. So now that we know we've done that, we need to do the opposite of that. We have a big number in B, and we need to turn it into a high and a low. So in order to get the high, we have to shift it over by 8. And in order to get the low, we need to mod it by 256. And then we need to set the RAM we need to set the RAM at A to the high bit, the RAM at A plus 1. Okay. I have a book on my shelf from Chips to Systems, goes over process architecture. If you need some bedtime material, I can let you borrow. It's a real snoozer. That's awesome. All right, cool. So we're still getting the same issue where we're getting an unknown instruction at 26880. So we are trying to do something a little bit wrong here. So that's not great. NAND to Tetris. I have no idea what that is. Rust log equals trace. Okay. So we have a whole bunch of stuff here. Am I crazy or is it not trace logging everything? How did it just print out all that? Oh, because it's, does it have to flush? Do you have to flush standard out by default? Should I just e-print it? Cool, now there's no debugging. Or now there's no buffering. So that jumped. Jump to A. Get value of self pointer 2. Self pointer equals A. Okay. Let's make some functions here. Let's make a jump function. And that way it can actually debug. I just jumped twice. Oh, plus equal 2 is not right here. Okay, that's good. Okay. Yeah, unknown instruction 26880. So that's clearly not right. Huh. Don't really know what to do here. Jumping to 369. Get RAM. We have a low of 0 and a high of 105. I think I know why it's messed up. Would you like my idea? No. No, please no. That error message is not going to be helpful. I can show you exactly where the error message is helpful. 396 is here. It's literally just a panic because of an unknown instruction. So this is supposed to happen. This means we're trying to run an operation, an instruction that's just not supported. We only have 22 instructions. So we're trying to run instruction 26,880. So something's wrong. We're just getting the numbers wrong. So yeah, something's wrong here. I crazy? $32,768. It's a 15-bit integer, so this is slightly above it, so it's a register. So when you have a high bit of 105, yeah, it's still within that range. It's still below 32,768. Okay. Okay. So right after it prints all that stuff to the output, the next thing it does is it literally tries to jump. At 684, we get a jump instruction. So we get the RAM at 686, which is a low of 113 and a high of 1. That makes sense. Jumping to 369. Pointer is 369. The number we pull out of there is 26880. That's just weird. So we jump. We get the RAM at 686. And then we just call jump. Don't do anything else down here. I don't know. It should work. The binary must be wrong. It's gotta be it. We get the RAM. Okay. Pointer equals 686. Jumping to 369. Get the RAM at 369. Yeah, because we're trying to get what's there as an instruction. That should be a way smaller number. So like our jump is wrong. Pointer is 680, then it calls out. We'll have to go double check all the places we increment the pointer. This wants to output a 10. 10 is a new line. Then we get the RAM at the next location. Which is a jump. The current instruction is set to jump. So we get the RAM at the next spot, which is 686. Which equals 369, and then we jump to 369. Now at some point, I never actually implemented this one. I thought that I did, but apparently I never implemented this one. Which is not a problem. We would be getting unimplemented if we hit it. We're not hitting it. That's just very interesting. So what does our jump function do? Super simple. Yeah, we just set the pointer to be that. We don't do anything else. We just jump there. This is just a jump instruction. Oh, well, you know what? We shouldn't unconditionally incremented here. We should do that. And we should do that. Doesn't change anything. It's still the unconditional jump that breaks things. Yeah, we're doing the JMP instruction. Pointer 684 is telling us to do that. Low high seems strange if low is higher than low. No, it's just the high and low byte of a 16-bit number. That's fine. This is how many ones there are, and this is how many 256s there are. So they're both 8-bit integers, and together they make a 16-bit integer. So a high of 1 just means 1 times 256, and then plus the low of 113, which gives you 369. Unimplemented is not like pass in Python. No, unimplemented will panic. It will completely break the program. So you can call panic, you can call to do, and you can call unimplemented. They'll all crash the program. So if we were hitting that unimplemented thing, we would just absolutely just crash the program and we would get a warning. But we are not getting that. We are correctly reading some value out of the RAM. But like, that shouldn't be right. So, let me see. Because all we're doing is we're outputting stuff correctly. Register value, extra mod with 8, possibly. All math is module 32, 768. I think that's going to be something. No, unimplemented will completely crash it. Highlight current search GUI background NVIM. Well, I'm not an NVIM, so I don't know if that'll work. You don't like this yellow? Is that what you're saying? Go double check that we're doing 3768. This is regular Vim, not NeoVim. If we get the value, oh no, we check it. We check it with our get rim value program. That checks it. That's good. Now when we push stuff onto the stack, okay. Jumps must land in the exact location the instruction should be executed. Are you sure you're not advancing the pointer after jumping? I was earlier, but I am not now. So, shouldn't be. Remove the top element from the stack and write it onto A. Okay. Get the register at A. Get the element. Put the element in the register A. What's up, Bash Script Kid? What a wild username. Is this like an architecture interpreter? Yeah, basically. We have to we're given a binary and the architecture spec for it, so we have to write a virtual machine to be able to execute the binary. So set A to 1. B and C are equal. This one's right. jump. Now, no, I'll think about that when we get to it. Yeah, mod 332.768, 32.768, okay. You made the username before you found my existence. It's rightfully my name. Nah, dude, that's awesome, man. That's so funny. Okay. 32.768. Store A, the bitwise operation of B and C. Bitwise OR B and C 32.768. This could be wrong. Read a memory address at B. Add address B. Write it to A. Yeah, that makes sense. Write the value from B into memory address at A. I don't know, hopefully that's right. Write the address of the next instruction to the stack. And sure. Let's try this. Okay. So all we're doing is just no op, then a bunch of outputs. And then we literally fail. We just hit a jump instruction and we just fail. All right, y'all, I'm going to hit the hay. I should be doing that too. I'll be sure to check the VOD tomorrow to see when you figure this out. I might not. I might actually just call it a night. But yeah, have a good night, man. It actually meant to be derogatory for myself. Like script kiddie. Yeah, dude, I totally get that. Saw a register number, mod 8. Yeah, there's probably something going on. All right. So all we do is call a bunch of outs, and then we call jump. Like, there's not anything fancy coming in. There's nothing fancy happening here. It's literally just the jump instruction that causes it to fail. Like, we jump somewhere, and then we read a bad instruction. So literally, let's just look at our jump our jump. Where is jump? Jump is here. Jump, we get A, we get the value out of A, and then we call self.jump. What else could be happening here? So it's got to be in our jump function. Function jump. Self.pointer equals pointer. How is this wrong? Jumping to 369. Like, that's not that far in the binary. You saw a bug like 20 minutes ago but didn't mention it. Not sure if you fixed it or not. Let me know if you want a hint. That's really funny. Not right now, but maybe in the next like 5 minutes. That's so funny. Get RAM. Get RAM is called by get RAM value, which clearly works. Maybe because this is calling get value on the pointer. I think it's something with my little endian, big endian thing. Nice thing is I only do it in one place. Yeah, low byte, then high byte. We get the low byte here. We get the high byte. And then to do that, we put the high byte first. So it's backwards, which makes sense. So we get the low of 113, the high of 1, which gives us the number 369. None of these are even in use. It's just the out and the jump. It's just a jump. Like, you should mod your register by 8 and not 32768. Register numbers are between 0 and 7. That's true, but they don't overflow. It's not like if I'm trying to access register 10 that I should go down to register 2. That's not how that works. Or register 10 should go down to register 1. That's not how it works. They're just invalid if it's too high. So I have a check in there that will just panic the machine if we're trying to access something that's too high. The only thing I can think of is that this is backwards. But like, how would that make sense? Yeah, okay, I think you fixed, yeah. Because I'm getting output, like, I don't know, I'm reading the RAM correctly. Like, at byte offset 684, we're finding the jump instruction. So that we'll get the RAM at byte 686. We've moved forward 2. That's where the next value starts. We've read a low byte of 113 and a high byte of 1. So, 256 plus 113 gives us 369. So we jump to 369. And then we get RAM at 369 so we can look up the instruction. And the RAM says that there's a 105 and a 0 there. So the instruction that we're trying to process is this. That's clearly not right. So where are we getting that wild number from? The instruction should be very, very low numbers. Oh my god, you can just read it. I can just read it. Welcome to the Synacor. Yeah, it's just right there. Huh. Here we go. Executing self-test. This is the part that, like, broke. We tried to execute the self-test and it broke. What's the jump instruction? Is it a... Jump is 6. That's nice. Executing self-test. T. 13 is probably out, right? Is that 19? Yeah, so this is T, or this is S out, T, and then we output a 2E. That's another out. That's a new line. That's a new line. That's a 6, which is the jump. So we jump to this. It wants me to jump to 7101. Here we go. So it wants me to jump here. These are hex numbers. So let's echo. I think we can do OX this. And OX this. So 113 and 1. And the 7-1 came first, so it's the lower number. So it's, I mean, this isn't wrong. It's just, I think we're jumping correctly. I just don't know what's happening here. Yeah, because this is how many 256s there are, right? Yeah. Yeah, so 256 plus 113 should be 369. There it is. And then it jumped to offset 369. Can I do this? Okay, 171 is what we want to go to. Which is here. So we're jumping there. And we're reading this. Are we supposed to jump one past it? That can't be right. The jump is supposed to take you exactly there, right? Did I misunderstand the spec? Jump to A. If a jump was performed, the next operation is instead the exact destination of the jump. The exact destination. So we jump to 369. We get the RAM at 369. And we have pulled out something really wrong. You think you know what's happening? That's interesting. Huh. Because I'm like out of ideas here. Give me like 2 minutes and then I'll ask you for the probing question, because I feel like I've run out of ideas here. Yeah, all we do is just vm.step, like it's not. Why is a hex dump 16 more useful than any other multiples of 8? I mean, it depends on what you're trying to look at. I'm just used to seeing hex, so like my brain kind of just does that calculation. But in certain cases, I could definitely see doing it based on multiples of 8s. Like looking at a byte at a time might be easier. Get RAM takes that. We get the value of this. I don't know if there's a 24 dump. Can you show the code that performs the jump? Absolutely, I can. You ready for this? So in order to do that, we get the value of A, which is either a register or a number. We get it by looking at self.pointer plus 2, because that's 1 past the operand. And then we jump to that location by calling self.jump, which is this function right here, which all it does is change our current pointer to be whatever we give it to the function. It's a basic setter function. So I can't see anything wrong with that. And then once that's done, then someone will call step again. We'll get the value at the pointer. And that value is apparently 2000 something, when it shouldn't be. Is using breakpoints allowed? Anything's allowed. Absolutely anything is allowed. The only thing we're calling is jump and out, though. That's why I'm just so confused here. Like, our out function works. We got output to the screen. Now, it might not be the best output, but no, our MD5 was correct, so... But get value read from the pointer, if I recall, get value reads from pointer plus something, right? Get value takes it as an argument. So we give it what we want to read it from. So we read from the current pointer plus 2. Then we increment it with 4. Makes sense. Then we encounter a jump instruction. Okay. And then we get value of pointer plus 2. Makes sense. And then we jump there. Can I borrow your beard for a day? Nah, I'm using it currently. Thank you, though. I have no idea. Yeah, Bob, if you have a probing question for me, I'm curious, because I'm at a little bit of a standstill here. We jump there. Let me get the RAM there. This is the first jump instruction. Yes. Up until this point, we haven't done any other instructions. I can show that with this. So here's all of the instructions we've processed so far. We've done 2 no-ops. We've done a whole bunch of outputs. And then at this one, we call a jump. Remember my hint from 2.5 hours ago? Nah, dude, I got no idea. What was your hint from 2.5 hours ago? I have no idea. Every number is modulo 32, 768. Was that your hint? I don't remember if that was your hint or not. Everything is 16-bit. Something like that. What's the size of the type you're jumping into? Everything is 16-bit. I don't understand. You're setting the pointer. Yeah, you're right. I didn't say it on the stream, but I had thought, I was like, I wonder if I should put an abstraction around getting address values because I'm going to have to constantly remember to times by 2 and divide by 2. I had that thought, and I just didn't do anything about it. Thank you, Bob. I don't know how long it would have found me to find that stupid thing. Oh my God, you've got to be kidding me. All right. Let me think about how I want to abstract this. Jump to, because I already have a jump function, which was very smart on my part. Jump to an address, because I think they call them addresses. Address 0 is the first 16-bit value. Address 1 is the second 16-bit value, etc. Jump to an address. There we go. Wait a minute. So then, wait a minute. Okay. Before I even implement that, when I do these write mems and read mems, oh man, write the value from B into memory at address A. When it says address A, I might have to do that same modification, right? I think I might have to. Yeah, dude. Okay. All right, because they're using the word address very clearly. Okay. Yep, I gotcha. Let's go ahead and do this. All right. Wait. I'm doing it backwards. It'll work, but we'll jump to an adder. And that way the pointer will be the adder times 2. There we go. Okay. That'll fix it. We still have some memory corruption with writing and reading this wrong. Okay. So, we're in a loop. But I know why. Well, I don't know why, but I have an idea why. I have a feeling we're calling W write mem or something. Okay, I don't know why. Okay. Interesting. Interesting. Can I just do this? Do I not have the timeout command? Oh, I see what's going on. Okay. Yeah, add address, add address, add address. Okay. Yeah. A lot of things need to change. We have something. LOL. There we go. I'm gonna check in that code here. This is a ton of fun. I'm really liking this challenge. This seems like a really cool challenge. This is really tough. Thank you, Bob, for that. I appreciate that. That's a hint that's totally allowed. I'm gonna call the stream here. I'm gonna call it a night. We've already been streaming for 3.5 hours. So thank you everyone for tuning in. I'll be back doing these. Obviously with Christmas coming up, I'm probably gonna be not as around. Just hanging out with the family and stuff. But yeah, thank you for tuning in, and we'll be knocking out this challenge. This has been a ton of fun. This is super cool. And Bob, yeah, nice job on the challenge. That's so cool because this seems like it's gonna get tough. So yeah, have a good night, everyone. Thank you for tuning in. If you're watching on Twitch, hit that follow button. If you're watching on YouTube, you better hit that subscribe button. Yeah, that's all I got. If you're on terminal, curl xmas.ysap.sh. xmas.ysap.sh. Check it out. Curl that. Pipe it to bash. And there you go. A beautiful little snowfall animation for you. Yeah, so thank you, everyone. Appreciate it. Thank you for the amazing course on bash. Yo, you're welcome. I am glad you guys are enjoying it. Oh, man. Oh, there won't be any heartburn. Don't worry. My body is built for late night pizza. I'm going to have some more slices of that. That sounds so good. So yeah, thank you for tuning in, everyone. Appreciate it. Have a good night, everyone. Take care. I will see you all later. See you guys.